All right, so I think this is recording. Let's take a look here at this problem. Read the problem carefully and identify what you're going to call thing one and thing two, and then press continue. All right, so I am going to call thing one this movement on this moving walkway that is with the walkway. So I'm going to, let's see, I need to move that up. I'm going to call this, what's my color? With, you're walking with the walkway, or you're walking against the movement of the walkway. All right, so see if you can fill out the information in the table and then press continue. All right, so let's see. Karen is on this moving walkway. The walkway is moving 4.75 feet per second. We'll worry about that in a second. 40 seconds, a total of 40 seconds. So I have a total of 40 seconds, and she travels 95 feet and then back again. So a distance of 95 feet with the walkway and then back 95 feet against the walkway. All right, so when you're walking with the walkway, it's helping you walk faster. It wants Karen's normal walking speed. We're going to call that x, and the 4.75 is helping her walk faster. She looks like she's moving super fast. And this is feet per second. Now, when you're walking against the moving walkway, it's slowing you down. So it's x minus 4.75. All right. Now, so she's here's the start of it. Here's 95 feet. She's walking here and then turning around and coming back. And that total time, that round trip total time was 40 seconds. But I don't know the individual, how long she was walking with the walkway and how long she was walking against it. It's not reasonable to assume, to say, there's nothing in here saying that it's 20 seconds each way. And we know that the total distance is 190 feet, don't we? But I don't think that's really going to get us anything myself, but maybe it could. All right, so there's always one of four possibilities when we have this uniform motion. We know that distance equals rate times time. Or solving the same equation in terms of time, that time is distance divided by rate. So it's always going to be one of these four possibilities of an equation that we set up, the relationship that we have in the table. So pick one of these four equations that you believe is going to lead to the solution to this, and then press continue. All right. So they are, the thing one and thing two is the same distance. So that's going to be a possibility. We said that the total time is 40, but that the individual time, that there's no reason to believe that that's evenly split to 20/20. So which of these possibilities do we want to look at? I think that if we go distance equals distance, you're replacing the distance with rate times time. Well, you can look at the table, rate times time, we don't know x and we don't know t1, so there's the rate times. We don't know x and we don't know t2. So we'd have one equation and three unknowns if we set those distances equal to. So I don't think this is going to lead us to anything we can solve. So we want to either look at the total distance and split it up into parts. Well, again, if we looked at the total distance and split it into parts, distance is rate times time, we're going to have one equation but too many unknowns. I think the one for us to explore is they gave us this total of 40 seconds, and to break that down into the length of time that you're walking with the walkway and the length of time that you're walking against it. So let's explore that relationship. So we're going to have distance divided by rate. So on the left-hand side, we're given that number. The total time was 40 seconds. And we want distance divided by rate for the thing 1. Well, distance was 95. And the rate, when you're walking with the sidewalk, that was the addition. Sidewalk's helping you move faster, moving sidewalk. And for thing 2, the moving sidewalk, you're walking against it, it's slowing you down. So we have one equation and one unknown. All right, so this equation is going to take us a little bit more time and effort to solve. Let's get rid of some of this stuff so that we can have a little bit of space. Of course, this is all in layers, so some of it's going to erase and some of it's not. Let's go to the other layer. So is that over here? Yeah. I'm trying not to erase my equation. All right. It's kind of neat that you can erase in different layers, but now I don't know which layer that little mark is, so I'll just have to live with that. All right, now, was this, well, that was the original problem. This, yeah. All right, so here we have a rational equation. Let's get a common denominator. So we want x plus 4.75 times x minus 4.75 is our denominator. So I'm going to take this 40 over 1 and I'm going to multiply it by the number 1. But I'm going to write the number 1 as x plus 4.75 times x minus 4.75. And I need that same in the denominator, so it will be the number 1. So I'm not changing the problem. So there's the left-hand side of my equation. On the right-hand side, this first term, in the denominator, we're missing the subtraction. We have the addition, plus 4.75, but we need an x minus 4.75. Since it has to be the number 1, the numerator and denominator have to be the same. That has to be able to reduce to the original equation up here. We did this when we solved rational equations earlier in the skill packet, back in part 1. All right. So all of these denominators are now the same. So all of these denominators cancel. So over here, we have a plus b times a minus b, which is a squared minus b squared. So x squared minus, well, let's take our 4.75 and square it. 22.5625. 22.5625. Is that right? Yeah. Now, let's be a little more clever. On the right-hand side here, I have two terms, and both of these terms have a 95. So I'll let you see that here. So rather than distributing that 95 to both terms right now, what I'm actually going to do is factor that 95 out from these two terms. So I've got 40 95 is common to that first term. If I factor it out, what I'll be left with is the x minus 4.75. 95 is common over here, so that gets factored out, and I have x plus 4.75. And you can see why I did that now to kind of help me out. That's a parenthesis. X squared minus because the minus 4.75 and plus 4.75 cancel each other out. All right. So if I double 95, I get 190. Here, let's shrink all this stuff up so we can have room to write. I don't know which layer this little mark is. Yeah, found it. Alright, let's go back to the layer that we're writing on. And because 2 times 95 is 190. And if we divide by 10, that will just take out those zeros. So this will actually be 19x, and this will actually be 4 if I divide both sides by 10. Alright, so let's distribute. Let's get this. This is a quadratic equation, and let's get this guy in standard form. So let's distribute the 4, and we've got 4x squared. I'm going to take away 19x, and then 4 times this next term. Let's use the calculator. Do we still have, hey, we still got that there. Let's multiply that by 4. 90.25. Alright, so let's use the quadratic formula to solve this. A is equal to 4, B is equal to negative 19, C is equal to negative 90.25. I'm going to find the discriminant first, break down the quadratic. Let's find b squared minus 4ac. That's the discriminant. That's the part that's underneath the radical. We have to find it anyway, so I'm just going to find it first. B squared is negative 19 squared minus 4 times a, which is also 4, times c, which is negative 90.25. So what number, let's help me with the calculator here. If we, negative times negative is positive, so I'm just going to key it in as 19 squared minus 4 times 4 times my negative 90.25. 1805. Now, we're ready for our quadratic formula. The opposite of b is the opposite of negative 19, which is positive 19, plus or minus the square root of our discriminant divided by 2 times a. Now, I suspect, let's look at this, what the square root of 1805 is. It's going to be bigger than 19. Yeah, so 4 minus that doesn't make sense that Karen's walking speed is negative. So even though the formula says plus or minus, it's only the plus that makes any sense. So we're going to use the posit. We need to add 19 to that. So there's our numerator, and then divide that. 2 times 4 is 8. Divide that by 8, and we're getting that her normal walking speed is approximately, let's just carry it to 2 decimals, 7.69 to 2 decimals, 7.69, and that was in feet per second. So this is Karen's normal walking speed. So this is a rare thing in one of these equations, one of these uniform motion problems, that the equation was actually difficult as much as the setup, because the equation was a rational equation. That rational equation led to a quadratic equation. That quadratic equation could not be factored, so we had to use the quadratic formula, and just the numbers themselves was a little bit large and a little bit awkward, but we let the calculator do the work, and so we came up with our final answer. We had to reason that we threw out the negative feet per second because it simply didn't make sense that Karen would be moonwalking, walking backwards. All right. Hey, I hope that helps. Don't be afraid to ask questions, and I'll talk to you later. Bye.